Some people wonder if the scientific method is even necessary. This is especially the case when it comes to psychology. People like my brother's unbearable wife, for example, they just know all there is to know about human behavior and human development. I don't even think she's taken a single college course, or I'm not even entirely sure she's finished high school, but she knows. You know, these kinds of individuals, they argue that the exact same conclusions could be reached using just plain common sense, or intuition, or logic, or faith, or some other kind of non-scientific method. And the truth is, sometimes they're right. Sometimes they are correct when they make these kinds of conclusions, and the science just supports their preconceived notions. But that's not always the case. You know, a broken clock is going to be right twice a day, but all those other times it's going to obviously not be so correct. So while these methods can produce correct conclusions, oftentimes it's just a shot in the dark, and you're probably not going to get very lucky. So one of the methods I mentioned is just using common sense, you know, just accepting information as true because many other people also believe it. There's a lot of common sense out there that just doesn't actually make sense if you think about it. If you do even the smallest amount of your own research, you'll realize that this stuff is just not true, even though everybody keeps saying it. One is, when the moon is full, it can affect people's behavior. People all over the world believe that the full moon can influence your behavior in some way. And this has been studied, and no scrap of evidence has ever shown that it can affect your behavior. There's a deeper underlying reason why this is a common sense idea, but I'm not going to get into that in this video. I have already talked about that in a different video. Another common sense idea is that something bad will happen to you if a black cat crosses your path. You know, these are common superstitions. But the one that I find the most upsetting, because I see it all the time, is when people say the sun, our sun, is yellow. I mean, just, I'm assuming it's daytime while you're watching this video. Just go step outside and look up. What color is the sun? Don't stare directly at it, of course. Just what color is the sun? Is it yellow? Or is it white? Answer is obviously white. I mean, if the sun was yellow, then it would only radiate yellow light, which is a very narrow band of the visible spectrum. And we wouldn't be able to see all the colors of the rainbow. So clearly, the fact that we can see anything shows, anything that's not just yellow, shows that we're getting the full range of radiation from the sun, not just yellow light. Yellow light is what people typically have in their lamps at home. And you can clearly see the difference. When you're inside, things look quite different than when they do when they're outside. Just take a photograph that's been taken inside and compare it to one that's taken outside, and it's a dramatic difference. And that's the difference between yellow and white light. But the interesting thing about this is people will just believe it and completely ignore what they see every day. Common sense can be very powerful. But obviously, it can also be very, very wrong. When all you're doing is just, you know, repeating what somebody else has said, it's impossible to determine how accurate those statements might be. And there's no real method for correcting these erroneous ideas. You know, you'll never question your ideas if all you do is just repeat what somebody else has already said. So common sense has some serious fundamental problems with it. So you might decide, instead of relying on what others believe, you should just go with your own instincts. You know, you should use your intuition, where you will accept information based on like a gut feeling, on the basis of like a hunch. So this is kind of an emotional way to acquire knowledge. But there's a lot of problems here. One good example of how this is a problem can be described in the phenomenon of framing. So just imagine this. Let's say you have to get some surgery, and the doctor says there's a 90% chance the procedure will be successful and you'll live. That sounds pretty good. I don't know if you would, say you would like to go ahead with that procedure or not, but I probably would. 90% seems like some good odds. But if instead the doctor said there's a 10% chance the procedure will fail and you'll die, that sounds pretty alarming. I mean, if you look closely, you can see it's the exact same odds. It's the exact same probabilities, but when people focus on the negatives, it makes people scared, and it can influence their decision making. So this is why doctors generally don't talk about the potential harms that could occur, because they don't want to scare you. They don't want to lead you to make a bad choice. So just going with your feelings can lead to some big mistakes. And just like common sense, one of the big limitations of using your intuition is that we have no way of separating legitimate, like actual information from these, emotional instincts. People's emotional states can change rapidly, and that can dramatically alter what kind of information is perceived. So if you can't trust other people and you can't trust yourself, then maybe you can trust an authority figure. Deferring to authority is a great way to acquire knowledge. Because usually if they are authority figures, then that means they actually do know what they're talking about. Authority figures typically have some expertise. So this is a good starting point. This is often the quickest and easiest way to obtain an answer. And if somebody is legitimate authority, then they typically wouldn't want to lie about this subject they're talking about. Like, I have no reason to lie to you about psychology or science. I wouldn't benefit in any way. So I hope you can trust what I have to say about those subjects. But there's some obvious problems when it comes to authority. One of the big limitations is, while they might try to accurately convey the truth of whatever subject it might be, that information may be garbled. It might be inaccurate, and that can lead people to some mistakes. Experts are people too. People can make mistakes. And a lot of times, people will accept this authority figure's statements without any judgment whatsoever. So you could call this the method of faith, like blind faith. It's like when a political person or a religious person just comes up there and starts explaining how the world works. There's a percentage of their audience that will believe anything they say. This is really scary stuff, and we've seen this a lot in recent times. It seems like no matter what that person does, no matter how dumb they appear to be, a percentage of that audience will buy into it, because they have that kind of blind faith. But then there's this last big aspect of this deference to authority that can be especially problematic, and that is if the authority figure isn't actually an authority figure. Not all experts are actually experts. And you see a lot of these supposed experts go outside the fields that they're experts in and try to talk about other subjects. So they're kind of co-opting their authority for things that they really don't know about and shouldn't be talking about. So experts can abuse their power, and people can pretend to have that kind of expertise just to try to influence you. So just obeying an authority figure, usually a good idea, but you have to make sure this person is actually knowledgeable of what they're talking about. But if you don't want to trust other people at all, like you don't want to accept authorities' opinions at all, you might decide to just go with pure logic, using the rational method. This refers to answering questions just using a very basic reasoning technique. It involves 3 steps. So step 1 is the first premise. In this example, all 3-year-old children are afraid of the dark. So that's our first premise. Our second premise is that Amy, just a little girl, is 3 years old. So based on those two premises, we can make a third statement, which is the conclusion. We can tie these two things together and say, therefore, Amy is afraid of the dark. So that's all logic is. You know, you have one premise statement and another premise statement, put them together, you get a conclusion. Very simple. The problem is that humans are terrible at this. Humans are not inherently logical creatures. There's a lot of room for error here. Like, either one of those premises could be factually wrong. Like, maybe Amy isn't 3 years old. Maybe not all kids are afraid of the dark. So we need to make sure that both premise statements are true before we can make a conclusion. But that conclusion could also be erroneous. We could, unfortunately, propose a conclusion that doesn't have adequate support from the premises, or just goes beyond the scope of those premises. So yeah, humans have problems with being perfectly rational. Here's an example. Here's another example. All cats are mammals. That's our first premise. Platypus is a mammal. That's our second premise. Therefore, platypus is a cat. Now, obviously, this isn't true, but do you see where we made a mistake here? Let's take another look at it. Is premise 1 correct? Yes, all cats are mammals. Is premise 2 correct? Yes, platypus is a mammal. So then it's the conclusion that must be flawed. Though all cats are mammals, not all mammals are cats. So what we did is we accidentally inverted premise number 1 in this case. And that's actually a very common problem that people have with being rational. Here's another example. All spiders hunt using webs. The tarantula is a spider. Therefore, tarantulas must use webs to hunt. So this is flawed. I don't know if you realize this, but this is definitely flawed. So where do you think the flaw might be? Do all spiders hunt with webs? Well, actually, no. Not all spiders do. Some spiders hunt by actively roving around and sometimes leaping great distances to try to catch their prey. So yeah, not all spiders spin webs to catch their prey. So that's a flawed premise, or a false premise. And here's just one more, because these are kind of fun. Children need love and affection. Children need food. Therefore, parents must satisfy their children's needs for food, affection, and love. Just take a moment. Can you find the problem here? Do these premises make sense? Are these premises accurate? Do children actually need love and affection? Well, the research says yes. In order for a child to develop properly, they need to feel loved, and they need to be given that physical kind of affection. And obviously, the second premise is also true. Children definitely need food. So there's a problem here with our conclusion, but do you see what the problem is? The problem is, in neither premise did I mention anything about parents. So this is an unsupported conclusion. Anybody could provide love, affection, and food. It doesn't have to be the parents. It could be a brother. It could be a cousin, or a grandparent, or just a friend. But children need those kinds of things in order to develop properly. So if you accept the fact that rationality is not probably going to work out for you, you might decide to just rely on your senses. And this is actually a great idea. Empiricism, the answering of questions by direct observation and personal experience, this is a big part of science. This is a fundamental feature of science. But pure empiricism without those other features is not such a great idea, actually. Here's some examples of how your perceptual experiences can be misleading. So take a look at this. This is what we call the color spreading phenomenon. So I'm going to put some colored lines on the screen, and I want you to look at the white area between the colored lines. Does that white area look perfectly white? How about this one? Does it still look perfectly white in between the colored portions? Compare the white right next to the blue lines to the white on the edge of the screen. Does it look to be the same? How about now? What most people would say when they look at this is that it does appear to have a faint coloration based on the color of the colored lines. So right now that white area between the blue looks a little bit bluish. But maybe this example didn't work out for you. So let me give you just a couple more. This is what we call the herring illusion. Sorry if this is a little bit painful to look at, but what I'm going to do is I'm going to draw two perfectly horizontal lines on the screen. So just watch how these lines are drawn. Did it appear perfectly horizontal? Just take a look at them. Do those red lines look perfectly horizontal, or do they appear to bend outwards once they reach the middle? How about now? Do they look more horizontal now? Well, most people would say yes. This pattern I put in the background appears to warp the direction of the line. Here's another classic illusion. It's called the Muller-Lyer illusion. Here we would just ask participants which line is longer. Most people would say the one on the right. But if we remove, the vertical lines, but if we remove those diagonals, you could see that the two lines are in fact exactly the same. So once again, you've been tricked into perceiving something that is not real. And here's just one more, because I really like talking about this stuff. It's fun to point out how bad we are at understanding the world through empiricism. This is what we call the stereokinetic effect. So if you look at the screen, all this is a bunch of circles, right? It's circles overlapping each other. But if I rotate the image, now it looks like it has some serious depth to it. It looks like a inverted cone, kind of. But obviously there's no depth here. If you're perceiving any depth whatsoever when you look at this, that is a lie. That is an illusion. Clearly this has no depth. So there's tons of these things. There's tons of visual illusions that clearly demonstrate how bad humans are at trying to make sense of the world by simply looking at it, or listening to it, or smelling it, or tasting it. These observations we make can easily be misinterpreted. Perception is a very creative process, in fact. We're always filling in the blanks, and there's a lot of blanks to fill in. Humans are not very good at detecting what's out there in the universe. Another thing that can affect this is that our perceptions, this creative process I'm describing, it can be swayed by our experiences, by our beliefs, by our desires. We develop what are called perceptual expectancies that can dramatically alter the way we perceive the world. And then one other big problem with empiricism is that it can be very time-consuming and sometimes dangerous. Like if you want to learn about, deep ocean animals, you're going to have to actually go down there, and you're going to have to observe. And if you do that, you're putting yourself at great risk. There's a lot of dangers that are inherent to that kind of research. But when it comes to all of this stuff about, all these things that can influence you and all these different sources that can, play on what you believe and why, one of the most powerful forces out there is, of course, the media. Public figures, people on the TV, people on the internet. These are the ones that are primarily responsible for perpetuating a lot of these common sense ideas. That they serve as authority figures, even though they, in many cases, clearly don't have any expertise in these areas that they're talking. People still perceive them as authority figures because they're on the TV, They're on the screen. They're social media influencers that are sharing their beliefs and often misleading people. So, just in my personal opinion, but I'm sure you feel the same way, people who are in these positions of power, they should be held accountable for spreading misinformation. As a wise man once said, with great power comes great responsibility. So you need to make sure you're not abusing that power. The world is full of truths, and many of them are unfounded or based on poor evidence, and it's often quite difficult to separate fact from fiction. But these kinds of beliefs are very common worldwide. This has led to the propagation of various pseudosciences, conspiracy theories, myths, and other kinds of ideas. But what I hope you get out of this course, hope you receive from watching these videos, is just a better ability to evaluate the quality of these kinds of statements, to understand better how this information was produced, and be more critical. For your own benefit, it's a good idea to just be a little bit skeptical. Now, I'm not trying to say that you should be negative or cynical or pessimistic. Skepticism is a very specific kind of thing. It just refers to pausing to consider alternatives and to search for evidence when there is enough at stake to justify doing so. So like if your friend tells you you'll probably like this movie, they just saw some movie and they are trying to convince you to watch it, that's relatively low stakes. You might as well just go with your friend's opinion. It's not a big deal. But if your friend is trying to tell you to not get your child vaccinated because it could harm them, well, your child's health is much higher stakes. It might be a good idea to question that friend and really make sure that this information is accurate. Because when it comes down to it, at the end of the day, you have something called an epistemic responsibility. You could call it an intellectual responsibility. This refers to the moral obligation to not hold false beliefs. And that might seem strange at first, but it makes sense if you think about it. No one's beliefs are truly personal. No one's beliefs are going to be kept entirely to themselves. People talk about this stuff. We share our beliefs and we actively try to convince others that our beliefs are true. So if, for example, you believe that vaccines cause autism, you probably talk about it quite a lot. Maybe you post about it on Facebook and Twitter, and every time you go to a friend's house, you complain about vaccines. People like to talk about their beliefs, and they like to convince others. So what I'm saying here is there's no such thing as a private belief, so you should be very careful that your beliefs are accurate. You should be very careful you don't mislead others, and the best way to do this is by using the scientific method. As W.K. Clifford once said, "It is wrong, always and everywhere, for anyone to believe anything based on insufficient evidence."